And so let's take a stock of what we have done up until now. So we are done doing a comparison of containers with virtual machine as per our previous video. What we are going to do is we are going to delve a little bit into the container architecture now, right? So what does container comprises of, right? So we're going to do this. Now, in order for us to do that, what I'm going to do is I'm going to make a small little drawing over here. There are some basic components on which the container architecture is based on. So we have, as we know, containers are Linux. Yeah. So we know that Linux implementation have got something called as kernel, right? I'm going to write that down. Kernels. Right. Now these kernels comprises of a few things. There is something called as C groups here. Right. C groups in Linux implementation takes care of resource allocation. All right. Let me write that down as well. Right. So what do you mean by resource allocation? Right. The container, what amount of RAM container is going to be having, the hard disk, and all those kind of things. And there is something called as namespaces. All right. Namespaces provide the segmentation in the container. Let me write that down as well. And then I'll explain what is the meaning of segmentation. All right. Let's say we have got these many containers here. Container number one, number two, number three, 4, and 5. Right. So making sure that these segments are created for containers is something that is ensured by namespaces. And allocating resources like RAM and hard disk is something that is ensured by C groups. Now the visibility between each one of these containers, just because namespaces have done the segmentation, is very limited, right? So visibility or interaction between these two containers is like very, very limited. But because these containers built on top of the kernel, the basic kernel, this visibility is always there. Right, remember containers are Linux, containers are like your apps in your phone or your host, right? Now when you say that a kernel can see everything or some of the things within the container, that means it kind of makes it a little less secure, right? So if you do ps aux, you should be able to see all these container processes. Yeah, these are application processes. So in order for you to make container even more isolated, there's an implementation called as SE Linux that you can use, right? All right. So when you use SE Linux on your containers, what happens is these containers become sandboxes, right? Individual processes where they would not be able to anyways interact with each other. Also, kernel will have the limited visibility into them, right? So that is some of the core concepts, the core fundamentals of the architecture on which containers are based on, right? In the next slide we will come back and in the next session we'll come back and see a slide where all these points are mentioned, right? So see you there.